Welcome to video 2 for this unit on area and surface area. In this video, we're going to focus on parallelograms. A parallelogram is a special type of quadrilateral, or a figure with 4 sides. The opposite sides of a parallelogram are parallel. It is also true that the opposite sides of a parallelogram have equal length, and the opposite angles of a parallelogram have equal measure. There are several strategies for finding the area of a parallelogram. First, we can decompose and rearrange a parallelogram to form a rectangle. For example, we can rearrange this parallelogram into a rectangle that has an area of 12 square units. So the parallelogram also must have an area of 12 square units. There is more than one way to do this. Another strategy is to enclose the parallelogram with a rectangle and then subtract the area of the 2 extra triangles in the corner. In this example, we can enclose the parallelogram in a large rectangle that is 6 units by 3 units. This rectangle has an area of 6 times 3, or 18 square units. To get the area of the parallelogram, we want to subtract the area of the 2 triangles we have added on each end. We can combine these 2 triangles to make a small rectangle with an area of 2 times 3, or 6 square units. 18 minus 6 equals 12. So the area of the original parallelogram is 12 square units. We can choose any of the 4 sides of a parallelogram as the base. Both the side and its length are called the base. Once we have chosen a base, if we draw a perpendicular segment from any point on the base to the opposite side of the parallelogram, those segments will always have the same length. We call that value the height. There are always many different places where we could draw the height. Here are 2 copies of the same parallelogram. For the example on the left, let's consider the base to be the side that is 6 units long. Its corresponding height is 4 units. For the example on the right, let's consider the base to be the side that is 5 units long. Its corresponding height is 4.8 units. No matter which side is chosen as the base, the area of the parallelogram is the product of that base and its corresponding height. Either way we calculate it, the area of this parallelogram is 24 square units. 6 times 4 equals 24, and 5 times 4.8 also equals 24. We can see why this is true by decomposing the parallelograms and rearranging them into rectangles. The length and width for each of these rectangles are equal to the base and height of the original parallelograms. That's why we can multiply the base times the height to find the area of the parallelogram. We often use letters to stand for numbers. If B represents the base of a parallelogram, and H is the corresponding height, then the area of the parallelogram is the product of these two numbers, b times h. Any base and corresponding height can help us find the area of a parallelogram, but some base and height pairs are easier to identify than others. When a parallelogram is drawn on a grid and has horizontal sides, like the shape on the left, we can use a horizontal side as the base. When it has vertical sides, like the shape on the right, we can use a vertical side as the base. That way, the grid can help us find the length of the base and the corresponding height. When a parallelogram is not drawn on a grid, we can still find its area if a base and a corresponding height are known. For example, which two numbers can we multiply to find the area of this parallelogram? If we choose to use a side that is 10 units long as the base, what measurement will we use for the height? Remember, the height is always perpendicular to the base. Since a corresponding height is not labeled here, that would make it hard to find the area. Instead, let's use the edge that is 8 units long as the base. Its corresponding height is also 8 units. Therefore, the area of this parallelogram is 8 times 8, or 64 square units. Thank you for watching video 2 of 5 for this unit on area and surface area.